We're going to start out explaining the periodic table first, and then we're going to go over to an example. So the periodic table is very complex, but all you need to know is that it's essentially separated into two groups for the purposes of this video. This over here and this over here are considered to be group A, while all these over here are considered to be group B. So something else that's very important for the example that we're going to do is that you learn about valence electrons. Now, to put it simply, valence electrons is the electrons on the last layer. And how are you going to know that? Well, you're going to look for a charge. So then there's a little table going to be provided for you, but all you need to know is that if it's in 1A, then the charge is plus 1, 2A plus 2, 3A is going to be plus 3, 4A is plus or minus 4. This is a middle point, so it doesn't matter. And then from here it goes minus 3, minus 2, minus 1. This one doesn't count for reasons that we're going to see later. So let's go over to an example really quickly. Okay, so they give you this. What do you do with this? So first off, you gotta look at your periodic table, and you're going to find out that nickel that's abbreviated by doing Ni. So you're going to write Ni. And what does this mean? Well, you're going to use this number. This is the amount of electrons it has. So you're going to use this number, and you're going to, let's say, just put it here for now. We're going to move it later. And then you're going to put Si, which is silicon. And then you're going to look in your periodic table for the amount of valence electrons that it has. So after you look for that, you're going to put a 4. So after you put a 4, this looks like it's resolved already, but it's actually not, because what these values actually are is nickel actually has 4 and silicon has 2. So what we do here is that when you have this, you need to cross it. So 2 goes to nickel and 4 goes to silicon. So what you're going to end up with is this, but if you may have noticed, this could be simplified. So you just erase a 2 and make this a 2. Whenever you have a number on the first part, which is what we call a cation, you need to put the values in Roman numerals. You don't have to do this for every single one, but it's easier if you do. And for every number or every word that's in the other half, you need to end it with IDE, because that's just how it is. So after you have this, that's all you really need to know. And that's how you do one of these examples. But let's say, what if they give you, or if they just give you Ni4 Si2? If they just give you this, and then they're gonna tell you to name it. So what you're just gonna do is you're going to cross it again. So 2 goes to 4, 4 goes to 2. You're gonna simplify it into this, and you're just gonna write out the names. You're just gonna write exactly this. Just remember to put these. Remember to end it with IDE, and you should be good.
Ions. Ions are elements with a charge, cation, and anion. The first step is to get the valence electron of the element, in this case magnesium, and magnesium have the valence electron of 2. Once you have the valence electron, you look the table and search where it says 2 electrons, and you know that is plus 2. So magnesium have a charge of plus 2. The first step is to find the valence electron of oxygen. The valence electron of oxygen is 6. Then you check the table and you find that valence electrons of 6 is minus 2, anion. Then in iodine, you know that it is 7 valence electron, and in the table 7 valence electron is minus 1, that is an anion.